So, good morning, students. Today we are going to discuss another important topic, that is Nernst equation and 24 years of NEET questions. Okay, so Nernst equation. Nernst equation. So, we studied how to find out the EMF of the cell at a standard condition. That is, at a temperature is equal to 25 degrees Celsius, which is equal to 298 Kelvin. Pressure is equal to 1 bar. Then molarity, concentration is equal to 1 molar. So at this condition we can find out the EMF of the cell, that is called E0 cell. E0 cell is equal to E0 of cathode minus E0 of anode. So the here these conditions are fixed. The concentration is 1 molar. So how will you find out the EMF of other condition, that is EMF is zero point 0.1 molar, right? Temperature is 30 degrees Celsius. Then how will you find out the EMF of the cell, right? For that, Nernst introduced an equation, okay? So consider a general equation, that is Mn plus, accepting n electrons and reduced as metal. M means metal, right? This is in the aqueous form, and here it is depositing as metal, a reduction. Now, so here EMF of the single electrode can be find out by Mn plus bar. M is equal to E0 of that electrode. E0 of that is in the standard condition that already given in the electrochemical series, minus RT by N of Ln concentration of a reduced state, that is in the product M, divided by concentration of Mn plus, that is in the oxidized state, right? Now, what are the constant? R is a constant, universal gas constant in Kelvin. Okay, R is equal to 8.314 joule per Kelvin per mole. What is T? Temperature is T means temperature. Now we are fixing as a 298 Kelvin. N means number of electrons transferred in the reaction, that will be varying for each reaction, it will vary. Then F is equal to Faraday's constant 96500 coulomb per mole. Okay, this is the value of F. Now concentration of M, reduced state, is equal to 1. Then convert Ln into log, okay, and Ln is equal to 2.303 log, okay. Give all this value in this equation. Now you will get EMF of electrode. This is equal to E0 of M n plus bar M, right, minus 0.0591 by N log of 1 by concentration of the solution. So this is the equation used to find out the EMF of a single electrode. Okay, for solving hydrogen electrode, we will use this equation for a single electrode. Okay, one electrode is there, its potential at any concentration. Here you can give the value of concentration of ion. So at any concentration, but the temperature we fixed as 298 Kelvin. Okay, if it is also not fixed, means you can give this equation, right? So this is important equation. So EMF is equal to its E0 value, E0 of reduction potential minus 0.0591 divided by N log of 1 by M n plus. What is N? N is the number of electrons transferred, or number of electrons needed to reduce the cation. Okay, so that is N. So this is a single electrode, EMF of the single electrode. So what is the EMF of the cell? So this is very important. E cell is equal to E0 cell minus 0.0591 divided by L log of concentration of the product divided by concentration of the reactant, right? So same thing only. How do you find out E0 cell? E0 cell is equal to E0 of cathode minus E0 of anode. Usually in the question itself given E0 cell, N you have to find out from the reaction. Concentration will be given in the question. Okay, right? Yes. For a general reaction, for example, say, for a general reaction, suppose I am writing a general reaction AA plus BB gives CC plus DD. So, what is the Nernst equation for this general reaction? So, you can write E cell is equal to E0 cell minus 0.0591 by N log of. Here you see what are the products. So forward reaction this side, okay. So the right side gives the product log of concentration of C into concentration of D. Is it correct? No. There one more thing you have to care. So what are the coefficient coming here? You have to write about this. Okay, powers. So here D is coming, so D. Like equilibrium constant. Okay, equilibrium constant you are writing like that. You have to write. Then here A to the power A, concentration of reactant, A to the power A and B to the power B. Just like equilibrium constant, writing equilibrium constant. Yes, okay. So I am giving on cell. Can you write the Nernst equation for that cell? So the cell equation is nickel solid is converting to Na2 plus aqueous Sawbridge Ag plus aqueous and this converting to Ag. So this is one of the cell given. You have to write the Nernst equation, corresponding Nernst equation. So here everything same, only this part only you have to write. So here cell only given. What's the value of N? Can you tell the value of N? You see, so for that we need the cell reaction. Then only we can write the Nernst equation. That is important. Okay. So in the anode, what happened? You see, anode, what is happening? Anode oxidation. So nickel is converting to nickel 2 plus. So 2 electron will be released. In the cathode side, what is happening? Ag plus. Cathode Ag plus is accepting one electron to form Ag. Right, this is happening, but you know that, okay, totally the number of electrons should be equal. For that, you have to multiply by 2. You have to multiply by 2. So this equation will become 2Ag plus 2 electron gives 2Ag. Now take the overall reaction Ni plus 2Ag plus aqueous 2 electron you can cancel gives nickel 2 plus 2 Ag aqueous. Okay, right? Now you see, okay, so this is our equation, Right? This is our equation. So can you write the Nernst equation? So E cell is equal to E zero cell minus 0.0591 by N log of concentration of the product. Okay, so that is nickel 2 plus. So no need of writing this solid. Okay, because solid we studied the concentration of solid is unity, right? Divided by, here what will come? Ag plus, so the Ag plus the whole square. Don't forget to write the square here. Okay, and the value will be wrong. So this is the right one. Okay, so next one is the, so of this much you understood well. One is the, what is the relation between the E0 cell and equilibrium constant. So in the Nernst equation we saw, the Nernst equation is just like that last part is like equilibrium constant. So is any relation between the equilibrium constant and the E0 cell? So at equilibrium, E cell is equal to 0. That's a condition. So at equilibrium, there will not be any current pass through the system. Why? Because the concentration, when, and I take an example of Daniel cell, when you are doing the reaction, zinc is becoming Zn2 plus. So after some time the concentration of zinc will increase. Copper 2 plus is becoming as copper, depositing as copper. So its concentration get decreases. So after some time through the system, there will not any current will pass through the cell. Okay, at that condition, E cell becoming zero and the equilibrium will be reached. At that time, equilibrium will be reached. Okay, so our Nernst equation, what is our Nernst equation? E cell is equal to E0 cell minus 0.0591 by N log of concentration of the, very simply I'm writing concentration of the product divided by concentration of the reactant. This is a general equation. So at equilibrium what will happen? E cell becoming 0 and the concentration of product by concentration of the reactant. So this will become equilibrium constant. You can write as K equilibrium. Okay, because at that time rate of forward reaction is equal to rate of backward reaction. So 0 is equal to E0 cell minus 0.0591 by N log of equilibrium constant. Okay, K equilibrium constant. Now take this E0 cell this side. So minus E0 cell equal to minus 0.0591 by N log of K or K equilibrium. Right, both side minus are there, so you can cancel out. So this is our equation. E0 cell is equal to 0.0591 by N log K. So how will you find out log K? Log K is equal to, take this one this side. So E0 cell into N divided by 0.0591. So this is important. Log K is equal to E0 cell, E cell becoming 0, no E cell, E0 cell into N divided by 0.0591. So this is the relation between the equilibrium constant and E0 cell of the reaction. Okay, right? Yes. So usually E0 cell is a positive quantity. So equilibrium constant is also a positive quantity. Okay, log of K will be a positive quantity. K you can find out by taking anti-log. Okay, when we are doing the problem, you will clearly understand. Then what is the relation between equilibrium, the relation between the EMF of the cell and free energy? Okay, you studied free energy delta G. It is standard condition delta G0 is equal to minus NF E0 cell. Okay, so delta G0 is equal to minus NF E0 cell. So E0 cell is equal to delta G0 divided by NF, this minus is there. So E0 cell is equal to minus delta G0 divided by NF. We know that for a spontaneous reaction, delta G should be negative. Okay, delta G0 is negative, so E0 cell is positive. Okay, E0 cell is positive. So condition, okay. So E0 cell is a positive quantity and delta G is a negative value. Delta G0 is negative. Then what is the relation between the equilibrium constant and free energy? Okay, what's the relation between the equilibrium constant and free energy? Delta Gr is equal to minus RT ln K. So this is another relation. Delta G of reaction is equal to minus RT ln K. Yes, now we can discuss last 24 years of neat question from Nernst equation. So first question for the cell reaction 2Fe3 plus 2I minus gives 2Fe2 plus I2. E0 cell is equal to 0.24 volt. The standard Gibbs energy for the reaction is. So we have to find out the standard Gibbs free energy how much. Okay. So options also I am giving. Option A 23.16 kilojoule per mole. Option B minus 46.32 kilojoule per mole. Option C minus 23.16 kilojoule per mole. Option D 43.52 kilojoule per mole. So this is your question. Reaction is given. So reaction is needed because number of electron we will get from this reaction only. Delta E0 is given. E0 cell is given. Then what is our equation? Delta G0 is equal to minus NF E0. E0 cell. Okay, delta G0 cell is equal to minus NF E0 cell. Right? So see, E0 cell is a positive value. So delta G0 cell should be negative. So you can cancel A and D. So two options by seeing itself we can cancel. Right? Now what is the value of N? N is C. Here is C. Okay. How many Fe3 plus is becoming Fe2 plus and 2I minus is coming. So one ion is losing one electron, so 2 ion is there, so N value will be 2. F value no. Now give the values. Okay, delta G0 is equal to minus 2 into F is 96500 into E0. E0 is 0.24. Right, we can, so two values are to a large difference is there, so you can find out by some tricks. Okay, right? So here If you multiply point 2 into 0.24, that is 0.48 minus 0.48 into 96500. So this is almost, I'm taking as 1 by 2, okay, 1 by 2 only. So minus 1 by 2 into 96500. So 9, 4 times 6. So 16, 8 times, right? 5, 15. So 8 times 5, 2 times. So 5, 0. Now it is in kilojoules. So 48 point. Simply we will get nearly 48. So not 48 because we have taken 0.5. So nearly 40. So option B minus 46.32 is the right answer. Okay. So this is the first one. So you can find out, okay, no need of the accurate value, okay, because you see the option, how the options are coming, okay, based on that you can take a whole number, okay, 0.48, you can take as 0.5 and do the calculation. Then you can write the next question. So second question, for a cell involving, one electron, E0 cell is equal to 0.59 volt at 298 Kelvin. The equilibrium constant of the cell reaction, how much? You have to find out the equilibrium constant, okay, right? What are the options given? Options: A is equal to 1 into 10 power 20, B option, so 1 into 10 power 2, C option 1 into 10 power 5, and D option 1 into 10 power 10. So if you know, pause the video and do the reaction, okay, do the calculation, right? So here reaction is not given. So what is the equation we studied? Log K is equal to E0 cell into N divided by 0.059. So this is the equation. So N value is given. So no need of the reaction. E0 cell is given. So we can simply do. So which is equal to 0.59 into N value 1 electron 1 divided by 0.0591, right? So here if you have doubt, then convert into decimal, okay, this you can write as 59 into 10 power minus 2. 59, if you multiply 59 by 10 power minus 2 points, okay, like that here you can write as 0.059, okay, so 59 into 10 power, or 59.1 into 10 power minus 3, which you can cancel, minus 2 minus 3, so here 10 power minus 1 will come, so 10 power minus 1 will be 10, right? Value will be 10. So log k is equal to 10. So k is equal to anti-log of this value, that is you give this value rise to 10. So 10 power 10. Option D is the right answer. So I will here, okay, this will cancel here, 10 power minus 1 will come. When you take it above, it will become 10. Okay, this value you rise above 10. Okay, that is the anti-log. Now you will get equilibrium constant. Next question, third question, okay, right? In the electrochemical cell, one cell is given Zn bar, Zn SO4, which is a 0.01 molar. Saltbridge CuSO4, that is 1 molar, becoming Cu. The EMF of the cell is E1. Suppose the EMF of the cell is E1, right? Then the concentration of ZnSO4, when concentration of ZnSO4 changed to 1 molar and concentration of CuSO4 changed to 0.01 molar, then what is the relation between E1 and this EMF we are taking as E2. The second condition EMF is taking as E2, then what is the relation between E1 and E2? Okay, option A, E1 is equal to E2. Option B, E1 is higher than E2. Option C, E2 is equal to 0, not equal to E1, and option D is equal to, option D is E1 is equal to, you are not equal to E2. So which is the right option? So first case, this is less concentration and this is more concentration and its EMF is E1. Second condition, water changing. So copper sulfate is 0.01 molar decreases and SO4 increases. That is, its EMF is measured as E2. Then what is the relation between E1 and E2? So you know the Nernst equation. So for this case, what is the Nernst equation? So EMF E0 is equal to E0 cell minus 0.0591 by N is 2 log of concentration of what will come? Concentration of the product. Here Zn is becoming Zn2 plus. So Zn2 plus concentration of Zn2 plus divided by concentration of copper 2 plus. So this is the basic equation. So you see, so first case here less quantity. Zn concentration is 10 power minus 2. So if you are doing this, it will come as minus 2 log 10. Minus 2 log 10. Minus 2 log 10. Copper 2 plus is 1 only. So not. So minus 2 into minus. So it will become 4 plus 0.0591 by 2 into 2. So these are becoming plus. So to the E0 cell it will add, right? So E0 cell will be a positive value. So into this is adding. So this will be a higher quantity. E1 will be a higher quantity. So see E2 what will happen? 0.05 minus 0.0591 by 2 log of Zn2 plus. Second case, the concentration is changing to increasing to 1 and copper 2 plus is decreasing to minus 2. So you can take this 2, this above will come, this is log 1 minus log 10 power minus 2. So you can take it 10 power 2, it will log 10 power 2, log 10 power 2. So this minus, so plus 2, it will be 10 power 2. So 2 log 10, the minus will be there, minus 0.0591 by 2. So here is a less value, minus is coming, so less value. So E1 will be higher than E2. So this is the, B is the right one, okay. E1 will be higher. So that means if you decrease the concentration of CuSO4, the EMF will also decreases, okay. So for the Daniell cell, if you decrease the concentration of copper, then the EMF will decrease. Okay, so that's the conclusion. Then we are moving to the next problem. If the E0 cell, so for a reaction E0 cell is negative, then which of the following is the correct relation for the value for delta G0 and equilibrium constant? So E0 cell is negative. Then what is the correct one? A option, delta G0 is higher than 0 and K equilibrium will be lesser than 1. B option, delta G0 is higher than 0 and K equilibrium will be higher than 1. C option, delta G0 is higher than 0, K equilibrium is higher than 1. D option, delta G0 is lesser than 0 and K equilibrium is lesser than 1. So this is the options given, okay. So which is the right one? E0 cell is negative. So what is our condition? So E0 cell, so delta G, delta G0 is equal to minus N of E. So this is negative means negative into negative. So delta G0 will be positive. So that means delta G0 will be higher than 0. Delta G0 will be higher than 0. Right? Then what is the relation between equilibrium constant? Okay, log k is equal to minus, sorry, log k is equal to E0 cell into n divided by 0.05 minus, right? So E0 cell is negative, then log k is also negative. So equilibrium constant will be, okay, that is the answer. Next problem is, next question, the pressure of H2 required to make the potential of hydrogen electrode 0 in pure water at 298 Kelvin is. So option A, 10 power minus 10 atm. Option B, 10 power minus 4 atm. Option C, 10 power minus 14 atm. And option D, 10 power minus 12 atm. So this is our question. So here we have to find out, okay, make potential of hydrogen electrode 0. So how much pressure of hydrogen is required? So here, what is the equation for hydrogen? 2H plus 2 electron gives H2. So this reaction is taking place in the hydrogen electrode. This reaction is taking place. Now, what is the pure water? So what is the concentration of pure water? So pH. pH is equal to, for a pure solution, it is 7. So what will be the concentration of H2 plus? H2 plus concentration will be equal to 10 power minus 7. Okay, this will be the concentration. You have to write 10 to the power minus. Okay, yes. Now what is the EMF for a single electron? We studied, okay, we studied that EMF H2. H2, okay, 2H plus, always 2H plus bar H2 is equal to E0 of 2H plus bar H2 minus 0.0591 by N. What is the N value? Okay, N log of concentration of the product, here H2 divided by H plus the whole square. Okay, right? So how you got H2? So this is the H2 and the here H plus square, okay, because coefficient is 2. Now you have to make the potential 0. So hydrogen electrode potential 0. Most standard electrode potential of hydrogen is 0 minus 0.0591 by N, number of electrons transferred, that is 2, log of, this only we have to find out, pressure of hydrogen, where the concentration H plus, so this is the concentration H plus 10 power minus 7 the whole square. Okay, right? So here 0 only, 0 is equal to minus 0.0591 by 2 log of log A by log B, log A minus B. So log of pressure of H2 minus, here on bracket is there, okay, don't forget to put this bracket, minus log of 10 power minus 7 the whole square. So 10 power minus 7 is 10 power minus 14, right? 10 power minus 14 will come, it's 10 power minus 40, right, which is equal to minus 0.0591 by 2 log of pressure of H2, minus into minus it will become plus 14, okay, plus 14. Now here this is equal to, I'm going to open this bracket, open this bracket, so minus 0.0591 by 2 log of H2, so minus will come minus 0.0591 by 2 into, okay, this I am multiplying, right, so into 14, so this will cancel 7, right, 7 you will get. Now we want this value, so you can take this term this side. Now it will be log of, so 0.0591 by 2 log of H2 is equal to, this term I am taking this side, okay, that only we did, so which is equal to minus 0.0591 into 7, right. Now I am we want the log of H2, okay, log of H2 we need, so I'm writing, okay, log of H2 is equal to, so divide this one by this, okay, so 0.0591 by 0.0591, this divided by 2, so here into 7 is there, this 2 will come above, so into 2 this will cancel, 7 into 2 is equal to 14, right. So log of H2, so here you can see, okay, log of H2 is equal to 14, so what will be the H2, so what will be the pressure of H2, which is equal to 10 power minus 40, right. So option C, 10 power minus 14 is the right answer. So how we did, so first write the reaction to H2 plus 2 electron gives H2, pH is equal to 7, right, pH is equal to 7, and H plus concentration, since it's a pure water, H plus is equal to 10 power minus 7. Now write the equation for Nernst equation for a single electrode. given this equation, then don't forget to give this bracket together, else you will not get the answer correctly. Then solve it, you will get a 10 power minus 14, that is the right answer. Okay, yes. Then moving to the next question. Next question, a hydrogen gas electrode is made by dipping platinum wire in a solution of HCl of pH is equal to 10 and by passing H2 gas around the platinum wire at 1 atm pressure. The oxidation potential would be the oxidation pressure potential would be how much will be the oxidation potential. So option A 0.118, B is much volt, okay. B 1.18 volt, option C 0.059 volt, option D 0.59 volt. So this is the question. So here the pH is given. So hydrogen gas only. So the same reaction last we have seen, that is 2H plus 2 electron gives H2 gas. This is the reaction and the pH is given as 10. So pH is equal to 10. So what will be the concentration of H plus? Concentration of H plus is equal to 10 power minus 10. Okay, that will be the pH. Okay, H plus concentration. Now we have to find out the oxidation potential. Okay, so EMF of 2H plus bar H plus, you have to find out E0 of plus bar H2 minus 0.0591 by 2 log of concentration of product. Okay, that is the pressure of hydrogen is given as 1 atm. So 1 by concentration of H plus is 10 power minus 10 the whole square. Right, so like that the last equation we did here, the pressure is given, H plus concentration you know. Now you have to find out the EMF of the cell. This is standard potential. Standard EMF of the hydrogen electrode is 0, that will give 0 minus 0.0591 by 2. Okay, this is also common, right? Log 1 minus log 10 power minus 20, right? Which is equal to minus 0.0591 by 2 log 1 0. So the term will be whole 0. This minus into minus, it will be, so log of so minus into minus plus log 20, or it will become water. So here you can write as, so log 1 0 minus into minus plus 20 log 10. Log 10, what is the value of log 10? Log 10 is equal to 1. So this term will be become 20. So the answer will be minus 0.0591 by 2 into 20. So it will be 10. So which is equal to 10 if you are multiplying on 0. So minus 0.591 volt. Minus 0.59. Okay. So option D Option D is the right answer. Very simple. So what we did, so we find out the EMF only. Okay, we find out the EMF of the reaction. Okay, right? Yes. Okay, next question. The Gibbs energy for the decomposition of Al2O3 Al2O3 at a 500 degrees Celsius is as follows 2 by 3 Al2O3 gives 4 by 3 Al plus O2. The potential difference needed for electrolytic reduction for electrolytic reduction of Al2O3 at a 500 degree Celsius is at least. So for this reaction, okay, Gibbs free energy is given as delta G reaction is equal to 960 kilojoule per mole. So what are the options? Option A 4.5 volt, option B 3 volt, and option C 2.5 volt, and option D 5 volt. So how will you do this problem? Okay, one reaction is given and it's a Gibbs free energy is given. Right, you know the potential difference. You have to find out the potential difference or EMF you have to find out. So what is the relation between potential difference, EMF and free energy? Study the delta G0 is equal to minus NF E0. Okay, right? So here you have to find out the EMF, potential difference you have to find out. Delta G0 is given. So N you have to find out. What is the value for N? So here what is the equation? 2 by 3 Al2O3. Right? You know for one aluminum charge is 3 plus, and in order to reduce one aluminum, how many electrons are needed? So 3 electrons are needed for one aluminum atom. Here how many aluminum atoms? 2 aluminum atoms are there. So 2 into 3 is equal to 6 electrons are needed for 2 aluminum. Here how many moles? 2 by 3 moles. So 2 by 3 into 6 is equal to 4 electrons. So in here what's the value of N? N is equal to 4. What is the value of F? F is equal to 96500 coulomb per mole. What is the value of E? What is the value of delta G is given? So from this E0 is equal to, what's the equation? Minus delta G0 divided by N into F. So from this you take this N of this side, it will become division. Now the values he give minus 960 kilojoule. So if you are converting to joule, kilo, 3 zeros he gave, okay, divided by 96500 into N value is how much? 4. N value is 4. So zeros we can cancel, right? It is 965. This is 960 and 60. So almost this will be 10. Almost, not accurate value. So minus 10, 10 by 4, it is 2.5, right? Option C is the right answer. Okay, 2.5 volt. 2.5 volt. moving to another problem, right? Another problem. So next question is the electrode potential for Cu2 plus electron gives Cu plus and Cu plus electron gives Cu or 0.15 volt and for 0.50 volt respectively. The value of E0 of Cu2 plus bar Cu will be option A 0.5 volt, option B 0.325 volt, option C 0.65 volt, and option D 0.15 volt. So if you know, okay, pause the video and you can do. Right, so two equations are given. You have to find out the value of E0. Right here, delta G value is not given. Okay, only E0 values are given. Right. So you write the first equation, that is Cu2 plus electron gives Cu plus, and the E0 value is 0.15 volt. Second equation, Cu plus electron is equal to Cu, then E0 value is equal to 0.5 volt. You see what is our equation? What equation we need? We need Cu plus is becoming Cu2 plus is becoming Cu. So if you add these two equations, you will get the value. Okay, right? But directly we can't add. So we are taking as delta G. 0 is equal to delta G01 plus delta G02. So this reaction corresponds to first one and this is the second reaction. So here you can minus delta G is equal G0 is equal to minus NF E0 is equal to minus NF. So I am giving E1 0 and here is N1 I am giving plus. So plus into minus NF E0. So minus NF E2 0. So this is for this reaction. Okay. When you add, no, adding on reaction will get that one. So here what is the value of N? So 2 plus is becoming copper. See, 2 plus is becoming Cu. So here the value of N is 2. F into E0 is equal to, here what, how many, N value is 1. So minus F into E1 0. E1 0 how much? This is E1 0 and this is E2 0. 0.15 minus N. Here also N values, how many electrons are transferring? Only one electron. So N value is 1. 1 into F. E2 0. E2 0 second value, okay, 0.5. Now you can divide by minus F. So all the term minus is there, F is there. So 2 into E0 is equal to 0.15 plus 0.5. Right. Now E0 is equal to, which is how much? 0.65 you will get. 0 is equal to 0.65 by 2 is equal to 0.325 volt. 0.325 volt, that is option B is the right one. Okay, option B is the right one. So like this only I have to find out. You can add, but delta G you have to convert to delta G. So you add and divide by this 2. Okay, 2 will come from here. So that is the correct answer. Next question, right? Next question is standard free energies. So delta G zero of formation formation in kilojoule per mole at a 298 Kelvin. The 298 Kelvin or minus 237.2 comma minus 394.4 and minus 8.2 for water then carbon dioxide and pentane CH2. The value of E0 cell for E0 cell you have to find out for a pentane oxygen fuel cell. Pentane oxygen fuel cell. So this is the question. Okay, options A 1.09 volt, B 0.09 volt, C 1.96 volt and D 2.09 volt. Okay, so you have to find out what is the E0 cell for pentane oxygen cell. So first you write that equation pentane C5H12 plus oxygen, so reacting with oxygen for the products carbon dioxide and water. Okay, carbon dioxide and water. Then what is the enthalpy? What is the free energy? Okay, standard free energy of this reaction you have to find out how much kilojoule. From that you have to find out the EMF of the cell. So first you balance this equation. So 5 carbons will give 5 here, 12 oxygen. So 6. So totally 6, 10 oxygen plus 6 oxygen. So totally 16. So 8 oxygen. So this is a balanced equation for this reaction. How much of free energy change will happen, right? So you can find out this from other 3 equations. So what is the first equation? Standard free energy change for formation of water. So formation of water, right? So formation of water. Formation of water. So formation of water means one mole is formed from its corresponding element. So here one mole. So half oxygen. So delta G0 for this reaction is minus 237.2 for carbon dioxide. So carbon plus oxygen gives carbon dioxide and delta G0 is minus 394.4, right? Then for pentane, so from carbon and hydrogen combined to form pentane C5H12. Delta G0 for this reaction is minus 2.8. So 5 carbon, 6 oxygen. Okay, right. Now we have it to see which equation we need. So pentane is in the reactant side, but here it is in the product side. So we have to reverse the equation 3. So I am taking this is equation 1, this equation 2 and this is equation 3. So first you have to what? Reverse the third equation. So reverse equation 3, that will give C5H12 gives 5 carbon plus 6H2. Delta G0 will be plus 8.2 kilojoule per mole. Okay, that will happen. Now, okay, reacted. Then 8 oxygen we needed. 8 oxygen we needed here. Okay, 8 oxygen. Okay, 8 oxygen it have to compare 5 carbon dioxide and 6 water. So here anyway you have to multiply by 5, right? Second equation you have to multiply by 5. So equation 2 into 5 give 5 carbon plus 5 oxygen gives 5 CO2. So here also delta G0 is equal to 5 into minus 394.4. Okay, I have to multiply that one. So 5 carbon then also equal to 6 water. So equation 1 you have to multiply by equation 1 you have to multiply by 6. Okay. So equation 1 into 6 will give 6H2 plus 6 by 2 is 3. O2 gives 6H2 and delta G0 is equal to 6 into 6 into minus 237.2. Right, now add all these equations. These three equations you add. Now here what will come? C5H12 plus 5 carbon plus, sorry, 5 carbon, here 5 carbon, here 5 carbon, it will cancel. So 5 carbon will not come. Then here 6 hydrogen, here 6 hydrogen, that will cancel. 5 plus 3, 8 oxygen will give, here what are the remaining? 5 carbon dioxide plus 6H2O. Right, everything other okay. Now if you do this one, you will get delta G0 value. Okay. So if you are doing this, you will get a 3385.8. Okay. If you multiply by 5 and here this equation multiply by 6, then add all these values, you will get a 3385.8. Right. Now delta, so for this reaction delta G0 we know. Now you have to find out the E0 cell. Okay, E0 cell you have to find out, right? So what is our equation? Delta G0 is equal to minus NF E0 cell. So E0 cell is equal to delta G0 divided by NF. Okay, minus delta G0 divided by NF. So delta G0 value is given 3385.8 divided by N. What is and how many electrons are transferred in this reaction? Right, you know one oxygen atom, it is O2 minus, so it will give 2 electrons. Right, so one oxygen molecule will give 2 into 2 electron, that is 4 electrons. Here how many electrons? 8 oxygen. So 8 into 4. So in this reaction 32 electrons will be transferred. Okay, so 32 into 96500. Okay, right. So if you solve this, you will get 1.09 volt. So option A is the right answer. So first we formed our required equation. From that we find out delta G0 is equal to minus NFE0. From that we can find out the EMF of the cell. Now write the next question. The equilibrium constant of the reaction Cu plus 2Ag plus gives C2 plus 2Ag. Solid aqueous, and this is aqueous and solid. E0 is equal to 0.46 volt at 298 Kelvin is option A 2 into 10 power 10, option B 4 into 10 power 10, option C 4 into 10 power 15, and option D 2.4 into 10 power 10. So what do you have to find out? For one reaction is given, you have to find out the equilibrium constant E0 value is given. So what is our equation? Log K is equal to E0 cell into N divided by 0.059. Right, this is our equation. So E0 cell, what is E0 cell? 0.46 into number of electron transferred. Copper 2 plus 2Ag plus. So how many electron? 2 electrons divided by 0.059. Right. So if you multiply, okay, multiply this one, you will get 15.57. Okay, 15.57. So log A is equal to 15.57. Right, so 15 is coming. So see 10 power 15. Okay, so log A is equal to some value into 10 power 15. So option C is the right one. Okay, 10 power 15. So this problem is also similar to the last one we solved. So the question is the standard EMF of galvanic cell involving cell reaction with n is equal to 2 is found to be 0.295 volts at 25 degrees Celsius. The equilibrium constant of the reaction would be A option 2 into 10 power 11, option B 4 into 10 power 12, option C 1 into 10 power 2, option D 1 into 10 power 10. So this is a question. Okay, here also same formula only, equilibrium constant you have to find out. So log K is equal to E0 cell into N divided by 0.059. Right, E0 cell is given 0.295 into, for a galvanic cell, you know, zinc gives Zn2 plus 2 electrons. So N value is 2 divided by 0.059. Okay, so if you multiply this to 0.89, okay, and this will be 0.4, okay, 0.590, okay, we'll get 0.590 divided by 0.059. So when you are doing cancelling, you'll get 10. So log A is equal to 10. So K value is equal to 10 power 10. Okay, right? So 10 power 10. So option D is the right one. Okay, so we have did all the question, 24 years of question which were asked in the NEET exam. Okay, so hope all of them understood. If you like, share and subscribe this channel. Okay, so goodbye. We will meet with another topic. Okay, so goodbye and take care.